way. So just, I'm not saying this is gospel truth. It obviously isn't, but it's just speculation on what might have been. So, and the majority of what I'm going to talk about is actually based on the contents of a book that was written about 20 years ago by a guy named Michael Molnar with the original title of The Star of Bethlehem. And he did a lot of research into this and found some interesting things that might explain what happened back then. And so I'm just going to summarize a lot of his findings here. So we see and hear about the Star of Bethlehem everywhere, especially this time of year. We see it on church banners. We see it on a lot of the Christmas cards we get or send to one another. But keep in mind, we obviously have no photographs of what actually happened back then. And like I said, the Bible itself doesn't even give us a whole lot of details. It just makes some vague reference to a star. And so remember, a lot of what you're seeing here is artistic license, thanks to the Hallmark Company and others over the years who have drawn up things that look exciting or have a nice feel to them, but there's no positive proof anywhere that this is what actually happened. And of course, some of the pictures we see aren't even factually correct. They show the Magi standing by the manger. Well, that's not what the Bible says. The Magi weren't at the manger. They came later. Or the shepherds seeing the star. There's no mention of that in the Bible. The shepherds were entertained by a heavenly host. It makes no mention of the shepherds seeing the star. It only mentions the Magi seeing the star. So we don't have a good idea of what really went on back then. So over the years, people have come up with various explanations of what they think it might have been based on the way our minds have been influenced by the Christmas card pictures. We naturally want to think of it as, it must have been some big, flashy, miraculous thing in the sky. And so what are some big, flashy things in the sky that it might have been other than just a miracle? Something like a comet, perhaps. But comets are relatively frequent if you're looking for them. They're visible by a lot of people, and they move fairly slowly over several months' time, so a lot of people might notice it. But back then, comets were actually seen as bad omens. They were associated with the deaths of kings and bad things happening. So for the people at that time, that doesn't really fit with the story. So it probably wasn't something like a comet. Another possibility is a supernova. In 3 words or less, a supernova is what happens when very massive stars hit the end of their life and run out of fuel to continue burning. And for various detailed reasons of atomic physics, they suddenly end their lives in a catastrophic explosion where they become incredibly bright for a period of a few days or so before they fade away again. So maybe it was something like that. But again, to people of that day, 2,000 years ago, who were charting things in the sky, they were more interested in the regular patterns of the stars and planets that were there every night. They didn't really pay much attention to transient things that only showed up occasionally. And also, we can go back and look at other historical records for the time around Jesus' birth, and there were people already watching the sky back then, so there actually are some records around, and there's no mention of any kind of supernova back at that time. Other possibilities are planetary conjunction. What that means in simpler words is that it's when some of the planets, the brighter planets in our solar system, like say Jupiter and Saturn, come very close together to one another on the sky. And that happens every once in a while, but again, it only lasts for a few days. And unless you really understand what it is you're seeing in the sky, normal people really wouldn't even notice or pay much attention to it. And as I said a minute ago, obviously it could have been some miracle that God provided. There's always that possibility. We don't know. Finally, some more modern New Testament theologians even speculate that, well, based on digging into a lot of the historical records and so on again, and the fact that the fact that only one of the Gospels mentions the event and the other three don't, maybe it never even happened. Maybe it was just Matthew's way of trying to convince people of the divinity of Christ. We don't know. Of course, we believe that Scripture was inspired, and we assume the Spirit did not coax Matthew to make up stories. So who knows whether that's the case or not. Sorry, I bounced it. So let's head straight to the actual words in the Bible. So continuing on from an hour ago, moving into Matthew 2, I hope I'm not stepping on next week's sermon. It says, after Jesus was born in Bethlehem in Judea during the time of King Herod, Magi from the east came to Jerusalem and asked, "Where's the one who has been born King of the Jews? We saw his star in the east and have come to worship him." When King Herod heard this, he was disturbed, and all Jerusalem with him. When he had called together all the people's chief priests and teachers of the law, he asked them where the Christ was to be born. I'm going to pause here a second just to highlight a couple of words that I want you to remember. The very first word, after Jesus was born. Again, the Magi weren't there at the Nativity. It was after Jesus was born. They showed up. When they asked Herod about it, Herod was disturbed when they asked him about it. Like this was news to him. He had known nothing about it up to that point. So if it was some big, bright, flashy thing in the sky, how come Herod hadn't heard about it until the Magi showed up and told him or asked him about it? And then moving on to the last verse or two, then Herod called the Magi secretly and found out from them the exact time the star had appeared. He sent them to Bethlehem and said, "Go and make a careful search for the child. As soon as you find him, report to me so that I too may go and worship him," which, as we all know, was a big lie. He had no intention of going to worship him. He wanted to find out where he was so he could go kill him because he was a threat. But there again, notice that Herod had to ask the Magi the exact time the star had appeared. Apparently, nobody else knew about it but the Magi. So what does that imply? So as I just said, maybe some of this has actually raised more questions than it has helped provide answers. Why were the Magi the only ones to notice? Herod was an incredibly paranoid guy. He was, I believe it's accurate to say, he even had some of his own family members killed off just to prevent them from taking over his throne. So he and his people around him would have been watching for things like this because they wanted to be aware of threats to him. And yet he appears to have not noticed anything until the Magi showed up. What was it exactly that they saw in the east? How did they know to then come to Jerusalem or to the area of Judea and Jerusalem when they saw whatever it was they saw? What was it about what they saw that made them think a new king of the Jews had been born? And whatever it was, it must have been pretty significant to convince them to travel like 800 miles each way by camel. That's not just jumping in the car to go over to the grocery store. That's a serious effort for their time. So first of all, who were the Magi? You could loosely refer to them as astronomers, mathematicians. Mostly they were astrologers. They were keeping track of the positions and motions of planets and stars in the sky and using them to create horoscopes for the rulers of the time. And because they had enough good records of the motions of things in the past, they were able to kind of predict where things were going to be somewhat in the future. And so because of that ability, they were perceived by common people as being, you know, some kind of magicians. Wow, these guys can predict the future. Well, it was just some simple math they were using. But anyway, because they were perceived as being some kind of magicians, that's the origin for the term in English that we use, the Magi. It's based on our English word of magician. All right, so if we want to go back and try to find out, you know, maybe from modern science and astronomy, what might have happened, first of all, we got to know when to look. Unfortunately, the people who set up our modern calendar missed it by about that much, and that's such that Jesus was not born in 0 BC. It's close. But if we go back and, you know, look at some of the information we have about that time, well, we know it was during the reign of Herod, obviously, which from historical records we know was between 37 and 4 BC. And we also know Mary and Joseph responded to this census that they were required to show up for. And there are records of 3 censuses around that time, one in 28 BC, one in 8, and one in 13 AD. Well, the 28 and 13, well, the 13 is definitely beyond the time of the reign of Herod, so that's too late. For other reasons, the 28 is probably a bit too early, so somewhere around maybe 8 BC. We can also look at a few other pieces of information, like when the ministry of John the Baptist took place. The Bible says it was in the 15th year of the reign of Tiberius Caesar. Well, his reign began in 11 AD, so if we then add the appropriate number of years to that, add the 15 to the 11, you know, we get somewhere around 25 or 26 AD. And we know that Jesus was about 30 years old at the start of his own ministry, which came just after John. So if you subtract 30 from the 25 or 26 AD, you end up somewhere around 4 or 5 BC, maybe, that Jesus was actually born. So close to 0, but not quite. All right, so now for the next 20 minutes or so, we got to shift our brains to think like the Magi would have been thinking 2,000 years ago and forget all we know about modern astronomy and so on to really try to figure out what it was that they might have been interested in at the time. As I said before, they were big on horoscopes. That was kind of one of their main jobs of, casting horoscopes for people based on their ability and records of positions of stars and planets in the sky. And a big part of astrology and horoscopes are the positions of the brightest objects in the sky, like the sun and moon, and the 5 planets that are visible to our eyes without telescopes. Those objects were very important to them, and they charted very carefully how they moved across the sky and what constellations they were in on any given year and at different times of the year and so on. And as I mentioned earlier, irregular transient things like comets and supernova were not important to them because they were irregular. They couldn't be used to predict things into the future. They didn't know when they were coming. If we go back and look at ancient Roman coins of the time, coins that were made for different regions of the empire usually had a portrait on them of the local emperor or even the local deity who was seen to be, a virtual ruler of the region in which the coins were being used. Well, this guy, Michael Molnar, found that some of the first bronze coins in the region of Antioch had a picture of Aries the ram on them. Aries is one of the constellations of the zodiac that figures into horoscopes. And so this suggests that it was Aries the ram that was seen as being significant for the region of Judea, where Jesus was born. So if we then translate that into the different constellations of the zodiac that are used for horoscopes and the records that we have from that time, we see that the sun was assigned to the constellation of Aries. So whenever the sun was in that constellation, or other things, which we'll see in a minute, are in that constellation, it was deemed as pointing to something going on in the area of Judea, because Aries was assigned to the region of Judea. The other thing they liked to do at the time for their horoscopes was that they broke the 12 signs of the zodiac into groups of 3, which they called trines. Think of our word triangle there. And the rulers of trine 1, which includes the constellation of Aries, are known to be the sun and the 2 planets, Jupiter and Saturn. So the presence of those planets somewhere within that trine would indicate something significant, again, in the area of Judea. So, what possibly was it that caught the Magi's attention back then? Where were the sun and the planets at that time? Well, we have a lot better records now than what the Magi had 2,000 years ago, and our ability to both predict where they'll be in the future as well as calculate where they were in the past is quite accurate nowadays. So we can just run a simple computer program, run them backwards, and find out, over a range of dates around the time that we think Christ's birth took place, where were these objects in the sky? So Michael Molnar came up with a very interesting result for the date of April 17, 6 BC. Remember, we said date-wise, we think his birth was somewhere around 4 to 6 BC, somewhere in that range. We don't have a good idea of exactly when it was. So in this image here of what the morning sky looked like at the time of sunrise on that date, you can see the sun just right on the horizon down there. This is sunrise. Jupiter, the moon, Saturn, and Venus are all slightly ahead of the sun in the sky. They rose before the sun so that you could see them for a little while just before sunrise. And then if you look down here, if you can see this in the image, the font color is not optimal, but the planets Mars and Mercury were just trailing the sun a little bit, so they would have risen just after the sun. But they're all clustered very closely together and all sitting within the constellation of Aries there on this date. And before you start thinking, April 17, well, that's kind of sacrilegious. What about December 25? Go home and Google Why is Christmas on December 25? You'll find out nobody knows why. There is no good explanation. The closest we can come is that there was a secular festival that had been going on for years and years already at the time of the winter solstice, which is around December 21 or 22. They celebrated the fact that just after the solstice, that's where the number of daylight hours in each day starts increasing again as the sun starts moving higher and higher in the sky again as you head towards spring. So they like to celebrate the rebirth or birth of the sun right around that time. And somewhere around 200 to 400 AD, somebody in the church decided, yeah, that sounds like kind of a good time for us to have our celebration too. So, all right, so on this date in April, again, as I just indicated, we have the sun on the eastern horizon at sunrise. Jupiter, the moon, and Saturn are just ahead of it in the sky. And so what does this mean to them in terms of the way they calculate horoscopes? I remember I said a few minutes ago that when the primary luminary or light of the sky is residing in its assigned constellation of the zodiac, which in this case is the sun in Aries, they see that as very significant. They use the word exalted. The sun is exalted when it's in its assigned constellation of Aries. And again, Aries at that time was assigned as being significant for the region of Judea. The second principle I mentioned just a minute ago. The sun, Jupiter, and Saturn on this date are not just anywhere within the three constellations of that trine, but they're all located in Aries at the same time. And so again, that just adds extra emphasis to the significance of something going on in the region of Judea. Finally, the fact that Jupiter was just ahead of the sun, in other words, it rose just a little bit before the sun at that time of the year, it would have been seen as what many of us like to call a morning star. You know, you can see it just before sunrise. Of course, once the sky gets too bright, you can't see it anymore. Again, back in that time, to these astrologers, they perceived that positioning of Jupiter and Saturn rising just before the sun as offering protection for the sun. We're not really sure what they meant by that term protection, but again, it just made the grouping that much more significant to them. So, what's really interesting is that when you look at how often this particular kind of arrangement of the sun, Jupiter, and Saturn, and the moon, and all those planets being all that close together to one another in that particular arrangement on the sky, you know, with Jupiter and Saturn preceding the sun in the sky, that happens about once every 300,000 years or so. So this is not a common event at all. And hence, to people like the Magi, this would have been like, whoa, this is big stuff. We have never seen this before. Okay, so carrying on with the rest of the gospel story, the second part of it again says, the star went ahead of them until it stopped over the place where the child was. This verse we have to be really careful with in terms of how we interpret our English translation that we're looking at. Remember, these aren't the original words. And even if these were the original words that the Bible was written in English, just the way we think of things over 2,000 years changes and so on. And so it's real easy for us to interpret those words in a different way than they might have originally been intended. Specifically, the normal motion of planets in the sky, if you go out and look at the position of Jupiter in the sky every night relative to the background stars, and it's true for all the planets, they slowly move from night to night from west to east. It's just because of the direction of the orbit they have around the sun with us. They slowly appear to move from west to east in the sky. And if we go back and actually look at the original Greek words in this verse, we find out the particular words that were used were actually fairly specific words that had particular meaning to, again, the astrologers of the day. Specifically, the word that we translate into went ahead, to them meant an object is going in the same direction as the stars move. Now, stars during the course of a night move from east to west. You know, things rise in the east and set in the west. And we just said normally planets tend to go the opposite direction. So this went ahead to them means, hey, the planets are going backwards from what they normally do. And this actually does happen all the time. It's a little hard to describe just by waving my hands, but simply because the Earth is moving faster in its orbit around the sun than planets that are out further from us, like Mars and Jupiter and Saturn. As the Earth swings around in its orbit and begins to overtake Jupiter or Saturn or whatever other planet is out there, they do appear to move backwards in the sky for a little while. And it's all just geometry, you know, the angle at which we're seeing them. And then after it does that for a little while, it goes back to moving its normal apparent direction again. Also, the original words that we translate as stopped over means this reversing of direction temporarily in the sky that we know the planets do. So, what was the planet Jupiter doing throughout the year of 6 BC? How was it moving through the sky during the months of that year? As we've already seen in the spring, in April, it was in the east, close to the sun, which is shown there in the bottom right corner of this image. It moved from west to east on the sky. Now remember, you got to switch your thinking. When you're used to looking at maps of the Earth, east is to the right and west is to the left, right? When you're looking at the sky, I'm facing south here, west is to the right, east is to the left, okay? So when the planets are doing its normal motion from west to east in the sky, it's moving to the left, which Jupiter was doing throughout 6 months or so of that year. Around August, it did its normal thing of stopping temporarily and then starting to move back to the west for a few months. It stopped again around mid-December of that year and went back to moving its normal direction to the east. So it's entirely possible that what the original author meant by the star stood over was simply this episode of the planet Jupiter temporarily stopping its apparent motion in the sky and then starting to move again after that. It's also somewhat consistent with the fact that, as we saw in the scripture reading, that the Magi did in fact arrive later, after Jesus was born. They didn't come to the manger. They showed up at his house in Bethlehem sometime later. Okay, so in summary, why were the Magi drawn so strongly to Judea? Again, why were they willing to hop on a camel and drive 800 miles to come and figure out what was happening based on what they saw? It's possible that what's referred to as the star in the east could be explained by this extremely rare alignment of the sun, moon, and all the visible planets clustered around the constellation of Aries at around sunrise in April of the year 6 BC. Because, as we've seen, so many of the things that the Magi considered important in terms of indicating the level of significance of an event all occurred simultaneously at this one time, they would have believed that, well, a really important royal birth has taken place. And again, because it happened in the sign of Aries, in the constellation of Aries in the zodiac, that would have pointed them to the region of Judea. So that's why they headed in that direction, possibly. So in summary, yeah, everything I've said here is based on astrology and the beliefs of astrology at the time. This is in no way meant to endorse astrology as a valid science, at least in my opinion. It isn't. But it's all they had at the time. They didn't have our modern day knowledge of how the universe works and the planets move and so on. And so I like to see it as God making use of the things he had already built into his creation to send a specific message that would be noticed by certain people who he knew would be watching for messages like that, to be part of the process of announcing and informing the people of the day that something big had just happened. So, as the pastor said earlier this morning about like water being a symbol, there's nothing magic about it. When I see pictures with the big bright shining star of Bethlehem in them, I like to think of that as symbolic of what happened, and that it might not have actually been the real thing that occurred. Okay, so that's the end of game one. We're in a doubleheader this morning. I'm going to take a brief pause while I run back and take over the pilot's seat in the back to quickly jump 2,000 years and transition to spending just a few minutes talking about and showing you some of the results from the Webb telescope. I'll, of course, keep talking and describing things from back there. And when I'm done with that, I'll come back down and, take your questions. So remember your questions for a few minutes. Talk amongst yourselves. Turn to the person next to you and say, "Kum," and then they'll respond with "Baya." Sorry, Ellen, I stole that from your brother. Okay, so while we're getting the pictures loaded up here, let me just tell you a little bit about the James Webb Space Telescope itself. You may remember the Hubble Space Telescope that was launched way back in 1990 already. It's been in orbit around the Earth for over 30 years now, doing magnificent work. It was built to operate primarily in the visible range of the spectrum. In other words, light that we can see with our eyes. Well, the James Webb Space Telescope was designed not to be a replacement for Hubble, but actually a complement to it. It is not only much bigger than Hubble, it's about 2 or 3 times the size that Hubble was. We can do that now just because technology has advanced in the meantime. But it's also built primarily to work in the infrared part of the spectrum, which we can't see with our eyes. It's longer wavelength than what we can see with our eyes. And the reason for that is just because by looking in different wavelength regions, I mean, we now have telescopes that look at things in the sky at radio wavelengths, at X-ray wavelengths, and gamma rays, you name it, all over the electromagnetic spectrum. By looking at things in different wavelength regions, we can find out different characteristics of the objects we're looking at. And so this telescope is meant to complement the work that's already been done by the Hubble in the visible range of the spectrum. And we're hoping that Hubble will keep working long enough yet, despite its advanced age, that we can do a lot of simultaneous observations with the Webb over the years. So this is just a picture of the telescope, an artist's rendition, of course, because we can't actually get a picture of it out in space. It's 1 million miles away from the Earth, so not easy to get pictures of. It's got a giant, shiny gold primary mirror on it. The gold is chosen simply because it works very well to reflect infrared light. And that's the region, as I said, that the telescope is built to work in. So let's look at some pictures. I hope you can see them as well as I can. They look fantastic on this high-res computer monitor back here. But this first image here, and actually the first several I'm going to show you, are primarily focused on relatively nearby regions within our own galaxy, regions of gas and dust clouds that are in our own galaxy where new stars are being formed out of those clouds of gas. Stars, after all, are just giant balls of hydrogen gas, and so they form out of just diffuse clouds of gas to begin with before they actually become stars. And the reason I concentrate on those for the first few pictures here is just because they happen to be so visually stunning and beautiful that a lot of the other real hardcore scientific research that can be done on other objects isn't all that impressive looking as a picture, at least not to a lay person. So anyway, this is a region here, like I said, in our own galaxy, giant region of gas and dust clouds. The gas is primarily molecular hydrogen, and what astronomers like to call dust are tiny bits of large hydrocarbon molecules that have formed out of the very cold material there out in space. To give you an idea of the scale of this image, first of all, from side to side here, from left to right, it's a distance of about 8 light years across. And if you don't remember exactly what the term light year refers to, it is not a unit of time, it is a unit of distance that astronomers use. It is the distance that light travels in 1 year. And we know that light travels really fast, right? It goes around the Earth 7 times in only 1 second. So in 1 year's time, light travels about 6 trillion miles. And so this view that you're seeing here is about 8 light years across. In comparison, Our little solar system of the sun and the 8 or 9 planets, depending on whether you want to include Pluto or not, has a diameter of about 10 light hours. So it's puny in comparison. I mean, if this big bright star in the middle here, I hope you can see the cursor that I'm wiggling around, if that were our sun, you know, our planets would fit in a space probably even smaller than what I can move the cursor here. That's how tiny our solar system would be in comparison to this huge cloud you're looking at. And the reason for the different colors that you're seeing, now remember this is taken in infrared light, so these are not realistic colors in the sense that we can't see this with our eyes, so there's no way, you know, to assign realistic colors to it. But the colors are assigned in a way where things that are bluer are warmer, and things that are redder are colder. So, for example, these dark red regions in some of the fingers of this cloud we know are very, very cold regions. Whereas if you look at, say, the tip of this cloud finger over on the upper left, you see how bright it is at the tip, and there's a lot of blue diffuse light. That is gas that's being energized and lit up by young massive stars that have just formed very recently that are just off the top of the field of view of the image, and all the intense light and heat coming from those stars is heating up the edge of this cloud finger here that you see. And so this next image, it's slightly different orientation than the last one, but just shows you a side-by-side comparison where on the left here is the image of this same object taken by the Hubble telescope, which is in visible light, versus the one we just saw on the right taken by the James Webb Telescope, which is out in the infrared. It gives you a little bit of an idea of some of the advantages of looking in the infrared. Over here on the left in the visible, all these regions of gas and dust are so thick and dense that visible light can't get through it, so they just appear black. And we see very few stars. In fact, the few stars that we do see are probably stars that are in front of that gas cloud. They're between us and the cloud. That's the only reason we can see them. Ones that are behind the cloud, we can't see at all. Well, now compare that to what we're seeing on the right. Infrared light, the longer and longer wavelength that you use, is absorbed and scattered less and less by dust and other gases, and so more of the infrared light is able to penetrate through these clouds, and suddenly we can see lots and lots of stars in these regions that are just completely black over in the visible. This is why fog lamps on your cars are yellow. Longer wavelength light can penetrate through clouds of fog and dust better than bluer light like your headlights. Okay, so moving on here. Here's another fairly nearby star formation region, very similar to what we just saw in the previous one. I just include it because they're just so pretty to look at. Again, lots and lots of dark and clumpy regions of gas out of which new stars are forming. Once little clumps of gas become dense enough, gravity takes over and they collapse far enough to get hot enough inside that nuclear fusion starts up and they light up and turn into a star. So after all, that's all stars are. They're just giant nuclear fusion reactors in the sky. Down in the core of the stars, hydrogen is being fused into helium and releasing tremendous amounts of energy in the process. So moving on here, yet another one of these relatively nearby regions. This one's a little further away. This one is actually in another small dwarf galaxy that's very close to our Milky Way galaxy. It's known as the Large Magellanic Cloud, and it got that name simply because it's only visible from the southern hemisphere. And so one of the first records we have of anyone ever spotting it, or at least writing down the fact that they saw it, was Magellan when he sailed around the southern tip of Africa hundreds of years ago. And so that's why these two dwarf galaxies, the large and small Magellanic Clouds, as astronomers have labeled them, have that name. But again, lots and lots of gas, out of which huge clusters of new stars are being formed. And let me just zoom in a bit here because there's a lot of resolution available that you're not even seeing when we're zoomed out. Just tremendous clusters of hot, bright blue new stars that are being formed out of that gas cloud. So moving on to the next one. This is going to the opposite end of the stellar life cycle. What we've been looking at already are regions where new stars are being formed. This is an individual star that's in the process of dying. This is a star that is about the size of our sun, and so in about 4 billion years or so, when our sun runs out of enough hydrogen in its core to continue shining the way it does, this unfortunately is what's going to happen to it. I don't think any of us need to worry about it. We'll be long gone. But on the left here is an image taken in near-infrared light by the Webb telescope, and over on the right is an image of the same object taken at even longer infrared wavelengths. You're seeing further and further into the infrared part of the spectrum. And you notice over here on the left, this big bright star, you think, oh, that must be the star that's dying and blew up and shed all this gas into space. No, that's not actually it. If you look over on the right in the mid-infrared image here, I'll zoom up on it so you can see it better. There are actually two stars down in the middle here, and it's the one on the left, the fainter yellowish star, that is actually the one that blew off all of this gas into space as it was in the process of dying. The brighter, bluer one immediately to its right is a companion star that is orbiting around it. So let me move on to the next one. Okay, this is one of my personal favorites. We're moving out farther into space now. Everything we've seen up till now are things that are quite nearby, at least in astronomical terms, within our own galaxy or very close to it. This is now moving out from our own galaxy to other galaxies in space. This group of what appears to be 5 galaxies, big one here, here, one over here, and this one here is actually a pair. You can kind of see that there are two galaxies very close together there, and that one in the top middle. So it may look like a group of 5 galaxies all very close together. In fact, that's not quite true. The big one in the bottom center here is actually much closer to us than the other 4. This one down below is only, and I use the word only in quotes, about 40 million light years away from us, whereas the other 4 that actually are grouped together with one another in space are almost about 300 million light years away from us. In other words, they're so far away, the light from them has taken like 300 million years to get to us where we can see it. But what you're seeing here, everything in the whiter, bluish colors are pretty much normal stars making up these galaxies. But what you see in like the yellowish, goldish shades of color are warm clouds of gas that are being heated up by the stars that are around them. And again, we can only see that in the infrared because, again, when I say warm gas, that's a relative term. Our bodies, assuming we're not running a fever, are at about 300 degrees Kelvin. That's 300 degrees above absolute zero. These warm gas clouds are around 100 or 200 degrees Kelvin, which for things in space is actually relatively warm. Without the big stars around them heating them up, they would probably be down at only about 50 or 70 Kelvin or so. And so again, because they are so relatively cold, only 100 or 200 degrees above absolute zero, most of the light that comes off of them is way out in the infrared. We can't see it with our eyes. Okay, and finally here, this is one of the first images that the James Webb Telescope has made of what astronomers like to call deep field exposures, where you just pick a spot on the sky and stare at it for hours and hours and integrate as deeply as you can to pick up very, very, very faint and distant objects. So what you're seeing here in the middle of the image, there's a fairly large cluster of very large galaxies. These galaxies are about, we believe, 4 billion light years away from us. But the interesting part about this is not just that cluster of galaxies, but more importantly, the effect that that cluster of galaxies is having on the things around it. You see these kind of circular arcs or streaks on either side of the cluster. Oops, oh, I hit the wrong button. I'm not a very good pilot. What's happening there, these are not some weird stretched out galaxies sitting there as part of this cluster. These are actually very, very distant, even more distant galaxies that are sitting somewhere right behind this cluster of galaxies. And so normally they would be blocked from our view. We wouldn't be able to see them. But what's going on here is that there is so much mass contained in this cluster of foreground galaxies. There's actually gravitational bending of light going on. This is something Einstein predicted could happen 100 years ago based on his theories of general relativity. And since then, in the last few decades, has been proven to be correct by observations like this. So what's happening is that there are galaxies, as I said, sitting behind this cluster, much more distant, way, way, way beyond this cluster. But as the light from them is traveling to us, as the light from them goes past this cluster, the intense gravitational field of this cluster of galaxies actually bends the light from these more distant galaxies and bends it around such that now all of a sudden we can see light that was originally right behind these galaxies, whereas now we're seeing it in these thin arcs spread out to either side. And in addition to just bending it so that we can even see them at all, they're actually also magnifying the view we have of these galaxies. And so we're able to see tiny features in them that without the gravitational lensing, as it's called, we would never be able to see because they would just be too tiny and too far away for even the Webb telescope to have enough resolution to find them. So in addition to that really interesting effect that's going on in here, I mean, the other thing that's just mind-boggling is that when we again zoom out to the full frame, everything you see in here, almost everything, this big bright thing with the spikes on it is a foreground star in our own galaxy, as well as a few others, but there are only about half a dozen of those in this whole image. Those are stars in our own galaxy. But everything else is a distant galaxy, just like our own Milky Way galaxy. And this is only a tiny, tiny blip on the sky that we're looking at. And so the thousands of galaxies that we see just in this one little image, if you think of the entire sky, I mean, our universe is literally full of billions and billions of galaxies as far as the eye can see. It is a truly remarkable home that God has created for us, and just points to the tremendous power of our Father and Creator. And I'm going to leave it at that before I get any more choked up just saying it. And I'm going to come back down front again and answer any of your questions if you have them. You can just leave that. Okay, I'm back. I think we have a couple of minutes for questions if anyone has them. And I'll warn you ahead of time, I am my brother's brother, so if you know my brother, hearing loss is hereditary. So if you have a question, shout it out to me. Yeah.
You said that there's constantly new stars forming. So how long do stars typically live?
It's a good question. The question was, in case you couldn't hear it, as I said, stars are constantly forming all the time and dying for that matter. How long do stars typically live? It depends on how big they are. You think of the old phrase of, live fast, die young. It kind of works that way for stars. Smaller stars have the longest lives. They tend to live for maybe 8 to 10 billion years, we believe. A star the size of our sun, we believe, has a total lifetime of around 8 billion years, and we think we're about halfway through that. Whereas much, much bigger stars, the kind that end their lives in giant supernova events, only live for maybe about 1 billion years before they blow up, so maybe about 1/10 the amount of time. So yeah, they're constantly being replenished by the new star formation going on. Yeah, Steve.
Car travel from St. Paul to Grand Haven is roughly 600 miles. When you say that a star or galaxy has traveled 4 billion light years,
Right, the light from it has, yeah.
so is there a point you can say now it's arrived here? How do you measure that distance if you only have like 1 point?
Yeah, so the question is, when we're looking at the light from distant objects that has taken millions or billions of years to arrive here for us to see, where was it when it started out? Well, that's kind of complicated, especially if you get into heavy-duty stuff that I don't even understand in terms of general relativity and so on. The theories surrounding the Big Bang origin of the universe say that, people tend to think of it or interpret it as everything in the universe is flying apart from one another. It's expanding because of some big explosion, that drove it apart. But that's not really the correct way to think of it. It's actually more like space itself is expanding constantly. And the galaxies and other objects in the universe are just riding along with it. And so it's not like that galaxy itself is physically moving away from us, and so it started closer, however long ago, and is now much, much further away. No, it's just that space itself is expanding all the time. And so theoretically, it's always been kind of the same distance from us. It's just the way we look at it that makes it appear to constantly be further and further away. And the way we measure the distances, there are lots of different methods that we measure distances based on how close an object is. There are different techniques that you can use. For nearby things, you use one technique. For very distant galaxies, it's primarily measuring what astronomers call their redshift. And what that means is all the elements in the universe, like hydrogen and oxygen and carbon and others, give off light at certain well-defined wavelengths when they're energized enough to do so. And so if we get a spectrum of these distant objects, we can figure out we see where it's lighting up at different wavelengths of light. We can figure out which elements just by the patterns of those wavelengths that are lighting up. We can figure out which ones are which. Oh yeah, this is the hydrogen series here, and these two are from oxygen. We then measure how much those features have been shifted in wavelength due to the fact that the object is moving away from us, or again, due to the fact that space is stretching, and so the wavelength of light is being stretched. And so that's how we can tell how far away and how fast it's moving, by measuring that shifting of the light coming from the objects. Yeah?
Did the early astrologers feel that the earth was flat?
I'm sorry, repeat that?
Did the early astrologers feel that the
Oh.
earth was flat or round, or how did they?
I'm not actually sure. The question was, did the early astrologers think that the earth was flat or round or what? I honestly don't know the answer to that. Yeah, it wasn't until... Right. Yeah, that's a good question. I really don't know. Of course, it wasn't until 1600 years later that people like Galileo and Copernicus and Kepler came along and figured out all these motions that these other people had been charting of things in the sky for so many years, figured out what actually causes them and how it all works and why they move that way. But I really don't know. Yeah?
Does distance have effect on time?
No, not distance.
The atomic clock,
Right.
even just going up a mountain, there was
Right. No, yes, actually, in that sense, it does. There's an effect of special relativity where the presence of mass and gravity, as I was just talking about in this one image, can affect the behavior of things, including light, or including the passage of time. The closer you are to a gravitational force, the faster time runs. And there's also the effect of motion, If you're moving faster, time slows down for you. And so that's why, in all the sci-fi movies, they talk about, people going out, moving at great distances at, half the speed of light or something. Time slows down for them. So yes, there are actually two effects, gravity and motion, that will affect the passage of time. The one you're thinking of when they put atomic clocks on airplanes, that's kind of a combination of both effects, because not only is the airplane moving, but the fact that it's 5 miles further away from the center of the Earth, the gravitational forces on it are a little bit less. And so that changes the speed at which the clocks run. Yeah.
I'll answer your question. Earliest date in the Hellenistic world was 5th century BC of the world being round. 3rd century Hellenistic world, it was common knowledge that the Earth was round. My question for you, going back to the Star of Bethlehem, at the end you culminated saying it was kind of all the heavenly bodies in Aries made up the star. I'm curious if you've seen the 2007 documentary, The Star of Bethlehem, which takes a lot of the same source material, but concludes as Jupiter and Romulus combined in the sky, sharing their light, making it a little bit brighter, and that's the star. Oh yeah, and the other planets and the planets of the
Are
sun
around
all
it. Yeah, I've not seen that.
Or why do you leave it more broadly when some are being a bit more specific?
Again, like I said at the very beginning, this is just one particular interpretation, and we don't know if any one of them in particular is the right one or not. This is just the one I'm most familiar with and caught my eye some years ago, but I'll have to go look for that one you mentioned. I'd be interested to see that. But it sounds similar in that it was, some kind of arrangement in Jupiter and possibly other planets that was the significant thing, yeah. Yeah.
Is the expansion of the universe slowing down, and is it ever going to stop and then reverse itself?
That's a really good question. And in fact, a colleague of mine at the Institute was actually part of a team that won a Nobel Prize a few years ago for that study, where it's been really, really hard over the last 60 years or more since we discovered that the universe is expanding to measure exactly whether it's on a trajectory where it's eventually going to slow down or continue to speed up or what. And the latest knowledge from this discovery, for which the Nobel Prize was awarded 10 years ago, is that it appears that the expansion is actually beginning to accelerate more now than it was in the past, which, if that holds out, would suggest it's an infinite thing. It'll just keep expanding forever, or until Christ returns, whichever comes first. We hope the other one comes first. Which one?
The big one.
It's not really moving much at all. Well, it's probably moving a little bit, but so slowly because it's so far away that we can't really see it moving much. Well, I don't know if we have a hard cutoff time here for vacating for the other church, but yeah. Sorry, say that one more time.
So like stargazing, were you saying like if we stare at it, we could kind of see into our future?
Not, well, the people who, like the Magi and other people who still follow things like astrology, think they can kind of predict the future by, seeing where the planets are going to be relative to the constellations of the zodiac, and hence predict what might happen. But as far as the scientific community is concerned, that really has no merit. And from the science side, when we study things like this with astronomy, mostly what we're doing is studying the past as opposed to the future. We're seeing the way things used to be.
Give Dr. Bushouse a hand for his time.
I don't know if you're allowed to end a church day with a movie quote, but I'm going to do it. It's a movie. I don't even remember if it's a good movie. It might be a terrible movie. I watched it on VHS when I was in college. It was called Contact, but there's a quote from that movie that I have written in my Bible. It says, "I had an experience," and as I looked at these pictures, I thought of it. I had an experience. I can't prove it. I can't even explain it, but everything that I know as a human being, everything that I am, tells me that it was real. I was given something wonderful, something that changed me forever, a vision of the universe that tells us undeniably how tiny and insignificant and how rare and precious we all are. A vision that tells us that we belong to something that is greater than ourselves, that we are not, that none of us are alone. I wish I could share that. I wish that everyone, if only for one moment, could feel that awe and humility and hope. And she says, that continues to be my wish. So may that be our prayer for those who would see this amazing universe. Thank you for your wisdom and your knowledge. My brain is very full as we close out today. But to know in the midst of all of that, we matter. So thank you for joining us this morning for worship and for Dr. Bushhouse's presentation. Thank you.